Hey, Chris, I just want to say thanks again for taking a little time to jump on the call with me here. As you and I were just talking about, really what I wanted to see if you're up for doing is take a little time. I know you've been doing some really great Tableau reports and whatnot for customers that maybe go beyond what we offer on in the standard packages and the standard Starburst and Trino UI. And if that's cool, maybe since we're recording, let me say my name. Hey everyone, I'm Lester Martin. I work here at Starburst and our Starburst Academy group here. And if you don't mind, Chris, just maybe a quick intro like yourself, and then if you're cool with it, let's just see what you got. I'd love to hear about it, and if you're okay with it, I'll just ask questions as we go
Yeah,
along.
definitely. So my name's Christopher Geisel. I'm a senior technical account manager here at Starburst. I've been with Starburst for almost 3 years. As of next week, have been here for 3 years. So what I'm going to talk about today is our Tableau integration. So we have a Starburst connector for Tableau, and a lot of customers really like it and use it all the time. I use it all the time, and I just want to share some of my tips and tricks with everyone. And I hope that people find it useful.
Oh yeah, they're gonna eat this stuff up. I hear clients eat it up already, customers all the time. So I'm looking forward to it.
Yeah, definitely. So what we'll do is I'm going to go through the basics, and then we're going to talk about the connector setup. We're going to talk about some of the uh, ways that you get started working with Starburst and Tableau at the same time. And then once we get through the basics, we'll authenticate to a Starburst server using Tableau, and we'll actually start building out some reports. We're going to build a basic report, and then we're going to build something a little bit more advanced. And hopefully, everyone finds that useful for getting started. Of course, there's always more to learn. I'm hoping that everyone can take this as a primer for how to actually start using these tools together, because there's a really great synergy here.
And Chris, I'm guessing the folks that'll get the most out of this already have some, Tableau experience themselves, right? Once we get into it, the terminology and whatnot you use probably will be more familiar to those folks than maybe a layperson in the Tableau world than me. Or
I'm not really good I feel like once you become an expert in something, the problem becomes it's really hard to put yourselves outside of that frame. So I'm not going to say who should and shouldn't watch this.
okay,
Um,
I like it. I
I
like.
what I will say is that when you're learning this kind of stuff, it's best to just follow along.
Yeah,
And it's like reading a book. The first chapter is always the hardest chapter.
right, right. And learn to do it. Yeah, absolutely.
So we'll just go real basic, and we'll start with our Tableau desktop page. This is where I recommend everyone get started. If you're doing this, is you go to our client documentation, you go to Tableau desktop, and you're pretty much going to be at the place you need to be to get this set up. Uh, the way that we're going to be setting up today is through the Tableau connector, and the Tableau connector is essentially native to Tableau. So you're actually going to see it when you install a base Tableau on your laptop. You're going to see in the additional connectors section the Starburst Enterprise connector. And that is supported through Starburst itself. So, in other words, uh, our company, Starburst, who makes Enterprise Trino possible. So, what we're going to be doing today is going through the installation of that Starburst Enterprise connector on Tableau, just in basic. So, you need to download a JDBC driver. You need to place it in your Tableau library. There's various instructions for how to do this. And then once you've done that, that's pretty much the installation done. This is the very basic installation. And the JDBC driver is totally free, and you can search JDBC driver up here and get a download link, and then just drop it into this folder. But once you click install, you're pretty much ready to go to the next step, which is connecting to Starburst Enterprise. We're now looking at a demo environment that we've set up for ourselves, which has this URL right here. So I need to actually grab the URL. That's the main thing. I already know my credentials, but grabbing the URL and then opening up Tableau and setting up a connection. So when I open up Tableau, you can see I have a few different workbooks that I've already done. I've done some preparation for this presentation. So what I need to go to next is actually describing to Tableau which server I'm going to be connecting to. So I'm going to go to the Starburst Enterprise by Starburst. And Tableau has been kind enough to already populate this for me because I've been connecting this server already. But if you're coming from this fresh, what it's actually going to show is it's going to show the port 8080, an empty username and password. It's not going to require SSL, and you're not going to have a role populated. So the server we're going to connect to is our demo environment, which has warp speed installed. We've got it set up so SSL is on the server. So you connect through port 443, and we are going to turn SSL on, and then we're going to set up our username, password, and role. So the first thing we're going to do is type in our username. For me, this is sa.chrisgeisel, and then I will type in my password. And then what happens now is you actually connect to Starburst. So I'm going to go and show you what is actually happening on the Starburst system at this time. Opening up this window, I'm actually going to set this. I'm going into our Insights UI, and I've already searched for my username here. What I'm going to go to right now is I'm going to actually set it to be after 10. So I'm going to remove this one. So because I'm on our catalogs, it's only my username. So this is showing everything after 10 that I've run. So let's even set it to the past minute. So you can see here that this is what Tableau's actually done to populate the various bits of metadata that it needs to go and help you build your notebook. So it's selected the Starburst version. It's run a simple select one query to verify the connection. And then it's listed out all of the table catalogs. And as we continue to go through this process, we're going to actually get into the schemas next. So we're going to see that in our um, insights view in a second here. So if I refresh the results, you can see here now it's selected that table schema. So everything that's happening, you can see live in the Starburst cluster. So we developed this tool so when you're using the Starburst Enterprise connector on Tableau, it's developed by Starburst engineers. And so we know our system really well and are able to make this really efficient.
Right.
And we've made a number of optimizations over the years as the product has matured. You can see here that like I'm going very basic here because when something goes wrong, if you have a connection error, it's also going to show up here. And so if you know how to connect to Starburst itself, you know how to log in, you should be looking at this query overview as you go through setting up this tool. Because if you have an error, the error is going to be a lot more intelligible within our Insights UI because it'll have the exact error code and you'll have a historical record of it. It's not just going to be something that's captured in your client and then sent as a log to Tableau. This is the way that you can understand it in your context. Continuing on, I'm going into our query logger. So for the uninitiated, the query logger is essentially the Insights database. So what we're going to be looking at today is our completed queries table. So I'm going to drag this table in. And again, everything that's happening here is happening on Trino. So if I refresh results, you can see that it's pulling bit by bit here. So I've opened up our completed queries table. One thing that I'm going to do first off with this is I'm going to talk about custom SQL. So everything that Tableau is sending to Starburst is actually a SQL query. So that's the first. If you're building a mental model of this, you've got the Starburst connector for Tableau. And then the Starburst connector for Tableau is essentially sending queries to Starburst over the HTTP through the JDBC driver, and then it's pulling that back and processing it in Tableau. So knowing those basic principles, we can then say, okay, well, I want a query that only deals with a certain amount of data that Tableau can handle, right? So Tableau is really good at handling what I would describe as laptop-sized information, whereas Trino really excels when we get to the gigabyte, terabyte, petabyte kind of scales that are harder and harder and harder to fit on a single computer's memory, and even impossible without super specialized expensive hardware. With this, what I'm going to run now is I'm going to run a filter for our create time. So when what this table actually is our completed queries table. And the completed queries table, basically, it's the thing that we've been looking at before on Insights. This is actually where Insights is storing it. So this is actually a live database
Yeah.
that we're querying against here today. So I'm going to run some date functions. I'm going to look at last month's data, which was December. So I'm going to set the month equal to 12. And last year was 2023. So I can just set the year filter. I'm going to do a nice line break there just to keep form of this same field. And I'm going to set this to 2023. And then we can do a quick preview of the results, make sure everything makes sense. So with the completed queries done and set up, I'm actually going to add in a little bit more complicated piece of SQL here. I wanted to, so for more complicated fields, Tableau is not necessarily going to be able to handle them as well, like specifically JSON fields. I find very difficult to handle within Tableau. So I'm going to do some JSON paths functions inside of my completed queries table here, just to add in an extra bit of layer to this presentation. I actually have this recorded, so you guys can follow my logic here. I have a JSON value that for failure info. And what I'm trying to grab from that is I want to grab the type of failures that we're seeing from queries. And I'm going to just put this into my custom SQL portion here. I'm going to go to the bottom and I'm going to create a comma, new line, and then I'll run a preview results here. And yeah, we can see that it is processing now. So we should actually get some results here once the processing is complete. And again, this is running on a uh, basically a Postgres database back here. So we're going to narrow results even further once we've confirmed that this in fact works. So this is one of the big differences between what Trino will do versus what Tableau will do by itself. When you are most people are used to Tableau, are used to using something that's already kind of prepared to. So we're going to look at the first 7 days in the month of December of last year, with the addition of this failure type using the JSON values function from Trino. All right. Click OK. And then what we're going to get started with next is actually building out a worksheet. So now that we have our table selected, let's figure out how to actually work on this best. What we're going to do first, though, is we're going to pause auto updates so we're not always querying Trino each time. And we're going to go ahead and fiddle with the fields that we have present in this sheet. So the first sheet that we're going to be building is going to just tell us where our queries are coming from on this server. So one of the most useful fields for that is going to be our source field. So that's going to be the source of our column. And then we're going to look at the number of distinct queries. So we actually have to set this query ID as a measure of count distinct. And the way this will look, we're going to run an update now. So we click the run update button. this will actually run a Trino query that basically has all this logic embedded with aggregates. So here's the result. Once it finished running, we've got a list of all of the different sources that are hitting this Trino cluster. So we've got Airflow, we've got different data products, we've got dbeaver, we've got insights, we've got Tableau, several different Tableau versions. We've got ThoughtSpot, we've got Trino JDBC being the highest count. And then we've got some Trino Python client here, and then some Trino SQL Alchemy. So mostly centered on Trino JDBC, but you've got all a good representation from a lot of the different clients that connect to Trino. So that's the first sheet that we're going to build. The next thing we're going to do is we're going to build another worksheet that actually goes through some more performance specific types of queries. So let's just make sure that we're not running auto updates. So we can fool with our fields without having to constantly query the cluster. So what we're going to look at, we're going to actually build a new measure. So one of the favorite ways that are one of my favorite ways to find which queries are running really well is to look at the parallelism of a query. And this is a field that I think is quite mysterious to most people. So hopefully we can demystify that a little bit. So we can think about the parallelism as essentially the CPU time over not the execution time, but the wall time. This is how it's actually defined. So the wall time is essentially how long you as a human being are experiencing time versus all of the times that the CPUs are spending together in terms of CPU clock. So what happens then, if we want to just describe this relation pretty simply with like, let's say you have a 4-core processor and that processor is fully dedicated to your query for the full duration of the wall time. Like let's say it's 1 second, you would essentially have a parallelism of 4 in that case. So it's the relationship between the CPU and your actual experience time.
Right.
So we're going to start by building that derived field as the parallelism. Okay. And then we're going to come up with actually another field that I like that's not actually in our default UI, which is the cumulative memory. I think people can use this in an interesting way here. So we can actually describe how much the query is using in terms of memory by deriving a few fields from the cumulative memory. So I like to create this field. And what this looks like is essentially we can move from cumulative memory, which is essentially bytes seconds. It's a derivative field, in other words. It's like rather than counting how many miles your car is going, you're counting how many miles per hour your car is going for a certain amount of time. So we can get to a much more sort of human sensible field here, which I'll call average memory in gigabytes. So we're going to first do the gigabyte conversion by just going from bytes to gigabytes by dividing by 1024 each time, 3 times. And then we're going to add in another section. I'm doing the parentheses as logical parentheses. We're going to convert from milliseconds into seconds by multiplying by 1,000 as well. And then this will give us the average memory in gigabytes that this query took up. So that's another field. So let's just make sure that I remove any calculation errors. Yes, I have a hanging parenthesis. Awesome. So with the average memory gigabytes set, we're going to basically build a report where we're not going to set these as measures. We're going to set them as dimensions. And you'll see why I want to do that in just a second. So when I get to the parallelism, I'm going to bring it up here. And then we're going to run, we're actually going to set this to live mode because what we want to do is we're going to turn this into a certain type of plot. So you can actually see there's some interesting relationships here where you can find different clusters of values. And I really like to look at this because you can see where the most common queries are. They almost cluster together. So if you're thinking in terms of like, how can I start doing smarter things with my Trino cluster, this is a really good place to start is understanding the relationship between memory and CPU. We're going to add in a few extra things here now. So we're going to pause this live portion of it, and I'm going to add in a few things here. So we're going to add in the source as a color, and then we're going to add in the um, we're going to add in a filter where we can eliminate a lot of those small values that are clustering towards the bottom so we can get a much clearer chart of the things we care about. So we probably don't care very much about anything that's going to be below 1 gigabyte, let's just say, of average memory usage, because that's not going to be significant in terms of performance for us in most cases. So now we can go ahead and refresh this. Okay, so now we've added in our coloring. So you can see all the different sources, and you can see a lot of Trino JDBC queries tend to hit the same types of things. Given this is a demo cluster, that makes a lot of sense because what's happening is people are hitting the cluster and getting kind of similar performance profiles for various patterns. And then some people veer off that in like left field. Like whoever did this one somehow got an average gigabytes of 918, which I think they probably did a scale testing at some point. It's just really nice to be able to visualize this. You get a clean visual, you can understand where queries are coming from. And if you find that Tableau isn't able to necessarily handle this amount of data to build this kind of chart, I would recommend narrowing your time range. And that should give you a good idea of how things are going to look. Okay, so I'm going to move on to the next worksheet, which is going to be the failure info, which is that extra JSON query I added to our Tableau. So the failure type is the derived field from the failure info. So the failure info itself is a JSON. Failure type is a traversal of that JSON to get that. So I'm going to pause again, as always, the auto updates. So I can just focus on getting the right data in here first. So I already have a good understanding of my data, which is something that we should all be working towards. And sometimes just building these Tableau reports can help there. You'll notice here that when I brought in the query set, it actually ran a query to get the filter list. So it's querying Trino to get the list of filters. It's running across all of the data that we have in this table. And then it's going to get me a list of the different types of and query states. And so what we do from here, now that we know that we're looking at only failed queries, let's go ahead and get the failure type, right? Because a failure type wouldn't exist in a non-failed query, right? So let's go ahead and add that failure type here. And then let's do another distinct count of our query IDs. Just as a reminder, the data we're looking at here is individual queries. All right, and now we go ahead and refresh this. Let's see how this ends up looking. All right, cool. So the query's finished and we've got our various failure types. We can see that we have a pretty skewed distribution towards certain failures. So let's actually find out what those are. So we can look at this failure type and see that it's a parsing exception.
Mhm.
The biggest, at least in terms of count of failure types, is a Trino exception, which is essentially a client and server connection error. This is either a client drops off or cancels the query, is included in this category. We've got access denied exception, and then we've got schema not found exceptions, which is you're querying on a schema that doesn't exist. Nice and simple. And then we've got certain very specific, what I will describe as catalog errors, where there's unknown table types. There's a verification base exception here from Google, which probably means that something went wrong with how it was connecting within the catalog. And then we've got S3 model exceptions, which probably means the um, S3 object either didn't exist or had some sort of problem with it. Those are the various failure types. These are three worksheets that you can go ahead and build if you're on Starburst in using your insights data. And there's a lot more to explore here. This is really just building that basic mental model. I'm going to build one more workbook type, and then you'll have all the tools you need to get started with this, I think. I'm going to go ahead and I'm going to remove, I'm going to start a new Tableau workbook actually. So I'm going to start a new Tableau workbook. So I'm going to save this book just for myself. And then I'm going to go open a new uh, Tableau desktop, and I'm going to reconnect just so we're starting fresh. Okay. All right. So I'm going to go ahead and open this, and I'm going to retype my password. Okay. So now we are in Starburst and we're reconnected. We're going to build a related set of tables using Starburst and Tableau together. So we're starting with TPCH, which everyone's going to have access to if they're running on Trino. It's one of our default catalogs that we usually deploy with, just so people can experiment with the tool itself. So let's go ahead and uh, build just a set of relationships that we can then use to build Tableau sheets. So this is kind of the more advanced types of thing you can do, especially on big data. So we can start building relationships between our tables. So we're going to build a relationship between orders and customers, right? So order is going to have a customer key and the customer is going to have a customer key. So we've built our first relationship. We can then go and look at the line items. So the line items will show us how, like, essentially how many parts, which parts were done for which order. And because this data is randomized, it's not going to be a super clean look when we actually get into building the um, dashboard itself, but you'll get a good idea of how you could build these types of relationships and maybe do some interesting things. And so now we're going to build a relationship between light item and parts. So the part itself is going to have a part key, or the line item is going to have a part key, and the part's going to have a part key. And so once you build that relationship, when you go into Tableau, you can open your worksheet and you can see all of these different fields with the accompanying table are listed out. And so go ahead and grab a market segment from this customer. And so for this market segment, let's just see all of the different let's go with the retail price of the parts. So we're going to do some of a retail price of the parts. This is it. So you build all those relationships, and let's go ahead and run this query. Now, it's not going to make any sense because it's, automatic data. So we should get a fairly random distribution, but you see how quick that was, right? And we can level this up to from SF1 all the way to SF1000. So let's do that now. So we're going to build the same relationship, but we're going to do it with 10 times the scale now. So now we're ready to create our next worksheet on the SF100 data. So we've got orders plus here. So we're going to do the same query. We're going to pause, and then we're going to the market segment. We're going to see how big our market segment is in terms of their buying capacity. Sum of retail price. And let's go ahead and run. So it came back. You notice that our null market segment is our largest market segment. Let's go back to the Insights UI and see what actually happened in Trino.
Cool.
Because what we want to do is just make sure we're understanding the relationship between what we're running and what's happening on the Trino system. So you'll notice that the CPU time I got was 10 minutes of CPU time for this latest query, and it took about 15 seconds to run. This, granted, this is a relatively minimal cluster, but let's look at the uh, different stages that we had. So you can see that the majority of our stages were um, done right here. But how many rows did we actually hit? The number of rows we actually hit were six. We were able to process 60 million rows or 600 million rows from this line item.
Hmm.
So we read a total of 845 million rows, which I don't think Tableau would be able to process on your local machine. So you can see we had to use 22 gigabytes of memory, even with this SF100 data set. And with a large enough cluster, we could scale up to SF1000, SF10,000. You could use this exact same Tableau notebook, just point it at the higher, um, the larger sizes of data that are present in the system. And the Trino system, because of its linearly scalable architecture, its MPP architecture, can accommodate a Tableau user running the same report on data that's constantly growing without the need to worry about Tableau resources, which are precious, especially as you add more and more users to things like Tableau Server. And we can help you offload a lot of that data. And so that's why Tableau is so valuable and why we have such good synergy with them. That's pretty much the end of my presentation. Lester, thanks for having me.
Yeah, no, it was great. You can't beat best in class tools. You can't beat a combination of two best in class tools to kind of get the job done. All right, well, take care of yourself, and I appreciate you taking the time.
Thanks so much, Lester. Bye.